All right, guys, good morning. You have yourselves your test tomorrow. So all old homework, anything from before the snow day, anything from the sign before the snow week, 6.5 and 6.6, both due today. 6.6 should have been done entirely online. 6.5 should be turned in whatever fashion you want. And today we're going to finish our review. Shouldn't take very long. We're just going to, simplify some roots, rationalize them, and talk about how to solve equations. And that's essentially what we'll be doing today. And speaking of, our warm-up today is about simplifying and rationalizing some roots. So let's take a look at these and see what we can do. All right, number one, we have the cubic root of 2 plus the cubic root of 4 all over the cubic root of 5. Here's number 1. Okay, this is particularly tricky. This is a skill that we talked about, but we didn't do a lot of, so I really want to make sure we get this down in the warm-up today. There's not a lot you can do. You can't add these things. They're not like terms. That's the cubic root of 2, right? That's cubic root of 4. There's nothing really you can break this down into either, can you? I don't think any perfect cubes going for. So there's not a lot you can do on top. And you can't really divide them because they're different things here too. So it seems like you can't do anything. The one thing they want you to do is rationalize the denominator. That means you don't want weird roots in the bottom, okay? That's just code for that. So what is on the bottom? Well, I got a cubic root of 5. Now, here's how you rationalize it when it's something like this. Well, I have a 5. I'd love it to be like a 5 cubed. Wouldn't it be nice if it was a 5 cubed? That'd be great if it was a 5 cubed. If it was a 5 cubed, then the cube root and the cube would cancel out, correct? That'd be great. Problem is, I don't have 3 5s under here. I only got 1, right? So what do? You put 2 more under the root. And that means right here, on this bottom, you're going to multiply it by a cubic root of 5 squared. And if you think about that, what's that do? You put these roots together now. How many are under the root altogether now? There's 3 of them, right? That's the big idea. Of course, if you do it on the bottom, you have to do it on the top also. So that's your strategy right there. You see a weird root on the bottom, just a weird root by itself. You multiply by the same kind of thing, but you put as many in there as you need so that it is a cube or a fourth or whatever you're having to deal with. And by design on the bottom, yes, like I keep harping on, this times this will be a cubic root of 5 cubed now, which is just 5. That's the point of this. You want the bottom to just be a clean, pretty number. On the top, it's a bunch of gross stuff. That's okay. That's what kind of the point of this. There's not a lot you can do. You can distribute this into both of these. You should multiply straight across. So this root times this, well, I'm going to put them together. What is 5 squared anyways? 25, correct? And 25 times 2, if I put them together under the root, is 50. So I can distribute that and call it a cubic root of 50. Similarly, you can take this cubic root of 25, distribute into this one, and multiply those two together. And the cubic root of what is 25 times 4 is 100. So I have a cubic root of 100 up there. And I don't think there's anything else you can do. If you actually go look down your list of cubes, none of them go into 50, nor do any of them go into 100. So there's nothing we can do to simplify any farther. So that's about as good as we can do. That's the trickiest thing, I think, that we haven't spent a lot of time on. Did that make sense there, what we did? Or do you have questions over it? It's okay if you have questions. I would understand that. Okay, guess not. So that's how you simplify a weird root on the bottom. You put as many down there as you need in order for it not to be a weird root anymore. Okay, number 2 is also about rationalizing the denominator. The denominator has some weird stuff in it. Square root of 2 minus square root of 5 here. And this one, you cannot use that trick because it's 2 different roots here, but you can clean them up with the conjugate thing. So the conjugate idea is if you have a root plus a root or minus a root, or there's a root down the bottom with a plus or minus, you multiply the top and bottom by its conjugate, which is square root of 2 plus square root of 5. And the magic of the conjugate, well, let's find out what happens. Just like the one on number 1 here, the top's going to get worse, actually, but the bottom's going to get pretty. On the top, if you do 5 times both of these, there's really not much you can do with that. 5 times both of them is just 5 times both of them. So I got 5 square root of 2 and 5 square root of 5. But on the bottom, as promised, things will work out nice and clean when you distribute out these conjugates. Square root of 2 times square root of 2 is just 2. And the square root of 2 times the square root of 5 is positive, correct? But on the very next term, this square root of 5 times this square root of 2 is going to be negative. So they're going to cancel out. That's why conjugates are awesome. And then the last thing when you FOIL it out, this times this is a negative 5. So on the bottom, you're just having 2 minus 5. Better known as negative 3. And that's your job. Your job is to get the bottom as simple as humanly possible. And I think negative 3 is pretty darn simple. So that's rationalizing it again. Those are the only two things that might come up with as to rationalize the denominator. Look at the bottom. If it's a weird root, multiply by whatever you need to, like in number 1, so that the stuff under the root is cubed. If it's a cube root, if it's raised to the 4th power, multiply by whatever you have to, so it's raised to the 4th power. And number 2, if you happen to have something weird like that, remember the conjugate trick, and then you should get yourself out of the woods. Lastly, number 3. Okay, these are always fun. This is the one other skill we need to talk about today, which is solving root equations. So here's my root equation. You got yourself square root of x minus 3, and then outside that's minus 3, and then x minus 12 on the other side. Your job, your strategy is always the same. Get the root by itself completely, and then undo it with whatever power is necessary. This is a square root, so in this case, we'll square both sides. But get the root by itself first. So the first thing we're going to do is add this 3 over. So square root of x minus 3 is now x minus 9 when I add 3 to both sides. And yeah, the whole idea is get the root by itself so you can undo it with a square. So you square this side, which means if this side has lots of things, you have to square that whole side also. And don't be killing any puppies. When you square this thing, you have to write it times itself, and you have to distribute it out. You can't square x and 9 separately. It just doesn't work that way. You got to write x minus 9 times x minus 9. And when you distribute that out, I'll put the like terms together as we go. It's pretty straightforward after this point. If you did all that, you'd get x squared minus 18x plus 81. And on the left, of course, the root's gone. That was the point. And now you're out of root world, of course, and you're just kind of going ahead and solve it like you would normal. It's a quadratic, so you set it equal to 0. You'd move the x and the 3 over. So if you subtract x on both sides, this side would now be minus 19x. And if you add 3 to both sides, this would now be 84. And of course, that equals 0. Gross looking thing here. It does factor, actually, I think. There are a couple numbers that multiply to be 84. Let's see, 12 and 7 actually do work for that one. And if you didn't know that, of course, you go with quadratic formula, correct? Never fails you if you sit there and factoring too long and you can't see the combination. That's okay. But x minus 12 and x minus 7 are both 0. So the answers are 12 and 7. That's what makes those factors equal to 0. But do not forget, when you are dealing with a root equation, to go back and check for extraneous solutions. When you solve these, as soon as you square a side or cube a side or whatever, you might add extra answers. So maybe these work, maybe these don't, maybe they both work, maybe neither. I don't know. We'll find out. We'll check them. So let's do 12. Here we go, 12. 12 minus 3 is 9, right? Square root of 9 is 3, correct? And 3 minus 3 is 0. So this side's 0. And clearly, when you plug 12 in here, 12 minus 12 is also 0. So 12 works. 12 is an answer. Is 7? Let's find out. 7 minus 3 is 4, right? Square root of 4 is 2. And 2 minus 3 is negative 1. Okay, so this side's negative 1. Although when you plug 7 over here, I don't think you get negative 1, do you? 7 minus 12 ain't negative 1. So 7 is the extraneous solution. So make sure you check. Don't finally, in the end, tell me that's an answer, because it's not. You got to go back and double check that your answers actually do work. That is the concept. All right, that's it for that. Let's go ahead and finish our review pretty quick, and then you will have some time to work or ask any miscellaneous questions you might have. LGs. Again, all old homework is due except for the review. The review is due tomorrow. And that kind of was the last of the review right there. We'll go through things a couple more times, one more time, and we'll do a couple problems, but that's essentially it. Can you rationalize the denominator and make the bottom pretty? And can you also just solve any weird root equation I give you? That's about it. So like I already said, all homework is due. Make sure you get that turned. It's not on the slide here, but 6.5 and 6.6 are both due today. Now the slides are finally caught up past the snow days. Test tomorrow, 6.7 due tomorrow. Okay, let's finish our review up. Here we go. Last couple sections in Unit 6. One was just kind of rationalizing the denominator, cleaning things up. That was one topic. Okay, we kind of brushed on that in the warm-up today, but the key thing is don't leave roots in the denominators. Any problems you ever do or solve, if you see a weird root in the denominator in the bottom, you got to clean that thing up. And the strategy is kind of what we already talked about. In the warm-up today, we had a weird root of something raised to a power in the bottom, and we multiplied the bottom by the same exact thing, but with maybe b's raised to other powers. We had, what, a 5 under a cube root, remember that? And it was a cube root, right? So you wanted how many altogether? You wanted 3 of them, right? You know, something cubed. So you multiplied by a b or a 5 squared to make sure that there were 3 of them right there. Same concept down here. This example here does a good job on the board. I love this one. It's a cubic root of 5. Well, how many 2's would you like to have under there? You'd like to have 5. There's only one, right? So what do? They force there to be 4 more. They multiply the top and bottom by a 5th root of 2 to the 4th. And that way on the bottom altogether, you have a 2 to the 5th, which turns into 2. And then the top can be something grosser too. If you have weird roots plus weird roots or weird roots minus weird roots, the key thing to do is use the conjugate. If you multiply the top and bottom by the conjugate of the bottom, you will be just fine, and that will clean everything up right there. And that was essentially all there was to that. The last section, solving radical equations, is basically you just need to get the root by itself, correct? Undo it with an exponent. So if you have a cube root, cube both sides. Make sure you do it to the whole side. Don't be lazy, okay? You can't just do it to terms individually. You got to do it to the whole side, multiply it by itself that many times. And make sure you go back and check your answers. Make sure they work. You should be able to get full credit on those because you can check every single thing. And I guarantee you'll probably always have at least one answer. There might be all extraneous. That is very possible. Okay, that was it for your review. I got nothing else to say about that. Any questions over content? Yes. Ah, okay. Yeah, come on down. I got one right here for you. Look at numbers 28 on. All of those are about just solving root equations. And that's kind of the only thing we haven't practiced yet. So if you have one or so of those you'd like to do, there's not that many of those kind of problems. 28 through 32 are all that kind of flavor. Anybody got any requests for any of those, or you just want to do them on your own? Yeah, let's figure that we do 31. Okay, 31 really is not as bad as it looks. Just like anything else, it never hurts to simplify things. No matter what problem I ever give you, simplify things. See what it actually is, and then we can deal with it from there. Now, if I just gave you this, forget the rest of the problem. If I just gave you this, I hope you think to clean it up. Would you agree? Well, 32 is something. You got your list out anywhere of perfect things? Maybe raised to the 5th? That'd be great, because this is a 5th root. Anything raised to the 5th that's 32. Anybody got confirmation? 2. Yep. So I can write this as 2 to the 5th. And this is a 5th root. So it's actually it's not as bad as it looks. It's going to clean up on this one. And actually, similarly, this is a cubic root of x to the 6th. I can simplify this one too. This can be thought of as something cubed because 6 divided by 3 is just 2. So I'm not even really getting a root by itself on this problem. I'm just simplifying things and see where it goes. In this case, secretly, there are no roots. It looks like it's a big complicated root equation, but if you simplify the roots, this is just 2x. Would you agree? And the second one, well, a cubic root of x squared cubed is just x squared. So in a really weird roundabout way, I'm just giving you some kind of rinky-dink quadratic equation right here. It's not even a root problem. It's just, can you simplify roots? And can you see that this is just a normal polynomial thing? Well, like any x squared thing, we'll get everything set equal to 0. So we'll move the 1 over. And that does factor into x plus 1 and x plus 1. Meaning your only potential answer is x equals -1. Ooh, so there's my potential answer. But like any root equation, now you didn't actually cube or square anything along the way, did you? So I don't think this is extraneous. But if I was doing a root equation, I'd go back and I'd check anyway, just to cover my butt. Well, let's see, -1 to the 5th. Well, a negative raised to an odd power is a negative. So this is a -1 times 32 is -32. The 5th root of -32 is -2. And this is, so let's see what else we got. This thing, -1 to the 6th is just 1. And the cubic root of 1 is just 1. So this side is -2 plus 1, which actually does equal -1. So it worked out right there. So that was more of an exercise in just, hey, I'm trying to freak you out by writing some weird radicals, but if you simplify them, it actually is a very, very, very straightforward problem on that. Cool. Now, I won't model the last page. If you go to the last page, that's solving by graphing. And that's just really, really boring. What do you got to do but solve by graphing? Just set it equal to 0, correct? Plug in your calculator, and wherever it crosses, draw me a rough sketch of it, and then write down the decimal version, right? It's the one time I'll take decimals, correct? Decimals are fine if you're solving by graphing. Otherwise, I need straight up algebraic answers with weird roots and all kinds of other junk. And that concludes your review. Any other questions? Anything at all? All right, you got the rest of the hour to work on things then. Don't forget that 6.5 and 6.6 are both due today. And your 6.7 that we just got done talking about due tomorrow when the test is.